For this problem, we have the integral of the square root of 4 plus x squared. So this has the form of a squared plus x of u squared. Since we have the square root of a squared plus u squared, then the suggestion is we let u be a tangent theta. And so we use this suggestion right here, then we would need to let a squared be 4 and let u squared be x squared. And then take the square root of both sides, we get a is equal to 2. And then let u squared be x squared. And again, take the square root of both sides, we get u is equal to x. And then the suggestion is to let u be a tangent of theta. But u is also x, and so x is equal to a tangent of theta. But a is 2, so we get 2 tangent of theta. And then dx d theta. The derivative of tangent is secant square, so we get 2 secant square theta. And then let's go ahead and work on this part first. So we have the square root of 4 plus x squared. So this is the square root of 4 plus 2 tangent of theta square. And then this becomes 4 plus 4 tangent square theta. And the common factor is 4, so you get 4 and then 1 plus tangent of theta square. And then one of our identities, one of the trigonometric identities is tangent square. 1 plus tangent square is secant square. So this becomes 4 secant squared. This is 2 secant theta. Now we start with the integral. So this becomes 2 secant of theta. And then, so the square root of 4 plus x squared is 2 secant theta. And then dx, we need to work out dx right here. So dx is 2 secant square theta d theta. So dx is 2 secant square theta d theta. And then this becomes secant to the third theta, and then d theta. Then we have a 4. And now we need to find the integral of secant to the third. And for this integral, we will use the integration by parts. And again, integration by part is u dv. And this is equal to uv minus v du. So we let u be secant of theta. And then let's go ahead and rewrite this one as secant square theta times secant theta and d theta. So let u be secant of theta, and the rest of it is secant square d theta, and we'll call that dv. So recall that to use the integration by parts, we look at our integrand here and pick something and label it u, and then the rest of it is the dv. And so now we have du d theta, and the derivative of secant is secant tangent. And so from here we have du is equal to secant theta tangent theta d theta. And then from here we'll integrate on the left, and then integrate the right. And nothing here, so we can put a 1. So we end up with v equal, and recall that the derivative of tangent is secant square, so antiderivative of secant square is tangent. So now our integral right here, this becomes uv minus v du, and uv is u is secant, u is secant, v is tangent. And then minus, and now in the v du, v is tangent, and then du is secant tangent, and d theta. And then this becomes tangent square theta secant theta d theta. So now we have the tangent square of theta right here. Let's rewrite that as secant square minus 1. Because tangent square is secant square minus 1. And then we have secant theta and then d theta. So now we have secant, tangent, and then we'll rewrite this right here. This is minus secant squared times secant is secant to the third theta, and then d theta, and then secant times 1 is just secant. But here we have a minus, and minus becomes a plus. So again, secant squared times secant is secant to the third. Secant times 1 minus 1 is minus secant, but we have a minus right here. Minus and minus makes it plus. And then the left side is this. The right side, the left side has secant, integral of secant to the third. The right side also has integral of secant to the third. So we move this term right here, we move it to the left side. And remember that when we move a term, if it's minus on the right, it becomes plus on the left. So we move this term right here, we move it to the right. And so now what's left is secant theta, tangent theta, and then plus secant of theta. Now this is one integral secant to the third, and then we have another one, so there are two of them. So this becomes 2 times secant to the third theta d theta. And then this is secant theta, tangent theta. And then recall that the integral of secant is the natural log of secant plus tangent. And then multiply both sides by 1/2. So multiply the left side by 1/2. And then we get integral of secant to the third theta d theta. And then multiply the entire right side by 1/2. And this is the solution, the answer for integral of secant to the third. So now we go back to our original problem, and this becomes 4 times all of that. And then 4 times 1/2 is just 2, so we get 2 secant tangent, and then plus the natural log of secant plus tangent and plus c. And this is the answer. And then we have to rewrite this in terms of x. So to rewrite it in terms of x, we'll go back right here. So we have x equal to 2 tangent of theta And so divide by both sides by 2, we get x over 2 is equal to tangent of theta. And recall that by definition, tangent is opposite over adjacent. And so to rewrite this in terms of x, we'll go back to the right triangle. So we have tangent of x is x over 2, and recall that tangent is opposite over adjacent. And so here this is theta, then the opposite side will be x, the adjacent side will be 2. And then secant of theta is hypotenuse over adjacent. So the hypotenuse is the square root of x squared plus 4, and then the adjacent is 2. And so we have secant of theta is equal to the square root of x squared plus 4 and divided by 2. And so our answer right here in terms of x, in the place of secant, we have the square root of x squared plus 4 divided by 2. And then in the place of tangent, we have x plus 2. And we can leave the answer like this.